part of what we'll go over with the permanent solution will not be completed until next year just because the design and some other things have taken longer, but it sounds like the short-term solution is held up as good as anybody could expect under the worst conditions. And then also talk about the fencing, some of those things, and give you a little bit better concept of what things are going to look like. And I think based on the conversations we've had, it's actually going to be a little bit more extensive what we're doing out back than we thought previously, but we want to make sure that we have the long-term fix and the right fix, one that lasts a long time. So from here, I'll turn it over to these gentlemen here, who are the experts on this.
Thanks, Lance. Again, I'm Jeff Smith. I'm working for MSD as the project manager. I'm working with Eric Arch with Rice and Jens. They are working on the final solution that we're going to show you here. As Lance was saying, there are a couple things I'm going to kind of close with a couple of the fence issues and some things we want to talk about still. So with that, I'm going to let Eric talk about this final design and give you guys a better understanding of what you're going to see actually out there. And then I can kind of close with the outstanding issues we still have to take care of.
Thanks. I guess I wanted to just provide some insight on how the long-term solution is going to look as compared to what you see out there now. We've been talking about this in several public meetings with you guys, and I think you have a general understanding of what we're doing is trying to protect that bank, and that's really the gist of it. As to how this project is going to look upon installation as compared to it is now, the big thing you're going to see is more of it. It's going to stretch from just beyond Vance Road to down here past the corner of your house, Clay. And the entire thing is going to be consistent with some stone protection. The upper portion, as we've discussed before, is going to be the biostabilization, so we're going to get some of that vegetative protection above the really critical water surface elevations that are going to be subject to the really heavy shear stresses of the water. So in general, the project is as we've discussed before. So I guess we can take a look at a few of the sheets here. Right here, we're looking right outside your house. This single striped area that you see here is what's there now, is the rock that's in place now. What you can see here is the extent of the long-term stabilization. So you can see that the scale of this plan is such that we have about another 150 feet downstream of what you see there now to be protected. I'm going to flip through just so you can kind of get a range of the overall project, and then we can get back into a couple of specifics. As we move forward, this is continuing upstream, the edge of your house is here, and as we move forward into this reach, we have what are called rock veins. I'll talk a little bit about what those are and what they're going to look like. Continuing upstream, we get into the section of Vance Road here, and then a final section of these rock veins. On the inside of the bend here, we have some biostabilization, and also at the top of the bank. So that's, in general, the limits of the project. In here, again, you can see where the existing rock is here at Vance Road, and the degree to which we're protecting in the long term. So the big difference, as I say, is the length of the project. What's not apparent on the plans is the depth of the project. And that's where Lance alluded to maybe some slight differences into what we originally were looking at versus what we're looking at now. Yeah, that's a good idea. Here again is a cross-section of the stream. So this is if you were standing in the stream, looking along the flow line. Up here we have the properties here in the back, and down in here is the existing rock protection, and this is the long-term rock protection. You can see again how much bigger this project is, but specifically how much deeper it is. The depth is a key part of this design that's going to provide that long-term protection. Following the installation of the temporary stabilization, we did some geotechnical work out here to determine how the soil profile is in the stream. As it turns out, you have, as you can see, a lot of stream bed gravel that's in the stream itself. About 7 feet below that is a firm clay residuum layer, and that's basically it's a channel within a channel. And what you have is, as you guys saw when the Ike came through, and in the previous events, you have a great deal of water that comes through this stream. During that time, it picks up a lot of the gravel that's in the bed of the stream and carries it and moves it and inches it downstream. The geotechnical borings that we did showed that depth of gravel movement is 7 feet approximately throughout, which is pretty astounding that much gravel transports down the stream. So to be able to provide something that's going to last, we had to take our rock protection down to that depth. In the past, these projects, let's say 10, 15 years ago, were generally brought to the flow line of the creek and just protect the bank. But the problem is when you have this sediment transport issue, they get undermined and then the rock starts to slump and they just don't last. So what we've got here is something that is built to last. So that's the really important thing as far as the depth of this structure. The height, you can see, is also a little taller than the one that's in there already. And again, that's to protect up to a certain level. Now, we're not putting this rock up to even the level that it got during this Ike, and that's intentional. The risk at that upper elevation is an infrequent event. That storm that you guys experienced they're still putting the data together, the USGS, but we're talking on the order of a 25 to 100-year storm. From a hydraulic standpoint, you can see the other side of the stream here. Once the water exceeds this elevation, it gets out into the floodplain, the stress is reduced. So we're actually extending this rock into a very safe zone, and that's important, of course. And then above that, we're going to get our vegetation and the biostabilization. So we go deep enough and we go high enough. That's the takeaway point there.
So if that were in place when the remnants of Ike hit us, then it would have been contained.
Correct.
Is what you're saying? Is that what
Right.
you're saying? Okay.
Yeah, this is probably, and correct me if I'm wrong, guys, this is probably a little bit of overkill almost, so to speak, but the big worry is because what's happening at the bottom of the creek bed when the water goes by. We don't want that same undercutting action to take place under what we put there.
Yeah.
And potentially be back here in 5, 10, 15 years, and perhaps even for more cataclysmic failure at that time.
Right.
So that's what this really avoids at that time.
So what you're saying by the sediment movement, that 7 feet, that basically all the rock that is between the air that you see outside and the clay bottom gets moved when it storms.
It potentially can move,
Okay.
yes. Yeah, it's, without some further data collection,
Right.
so it's hard to tell exactly the depth to which it moves, but we notice that there's a distinct change in geology at that depth, and so we want to protect down to that
sure.
level.
Yeah, you see those whole dunes or whatever pushed around and everything.
Yeah.
It's just totally made over after something big like that.
Right,
So.
and you'll see another. If we go to another stream in a nearby area, it may not be the similar situation. It's really about the geology of this stream that is creating this issue, and as well as just the magnitude of the flows that we're talking about. So that combination requires some, as Lance says, maybe something heavier duty than we would normally do in this type of situation. So it's about minimizing the risk of failure.